Hello everybody and welcome to the first of two videos for solving trig equations. Hello everybody and welcome to the first of two videos that will be going over solving trig equations. We'll be using some of our knowledge from Unit 3 and also be using a lot of identities that we've been using the last couple of videos here in Unit 5. So some strategies that we are going to use eventually to help us solve trig equations is we want to isolate or get the trig function alone, so get sine, cosine, tangent, all on one side and everything else to the other side. We can use algebra like we've been using in the last couple of videos. We could factor, multiply, combine like terms, make two fractions into one, manipulate things a bit. Or we could even use trig identities to convert from one type of trig function to another. Now, what's useful is that you generally want all of these equations to eventually be in terms of one trig function because it's eventually easier to solve. And so that will come up right now. So if I looked at this first equation, if you do not have your unit circle out, I would really consider pausing the video now and grabbing either a unit circle plate or your Unit 3 packet, because there's going to be times that I ask you to try things on your own first, so it's good to have your unit circle in front of you. So my goal of this first one is to solve for x. So first I want to isolate the trig function sine, and then I want to use my unit circle. And what this means again is you're going only around the unit circle one time. So it's every answer that's true in one rotation. So let's isolate the trig function. Let's first subtract the 1. Then the trig function is not yet isolated until you divide both sides by 2. So you have sine of x equals -1/2. So we're asking, where does the y value equal -1/2? On the unit circle, because you might recall sine really means y. So if I look at my unit circle, the places that I see the y value being -1/2 is here at 7 pi over 6 and here at 11 pi over 6. So my two answers in one rotation, my angle would be 7 pi over 6 and be 11 pi over 6. So we had a ratio and our answers were an angle. I would highly suggest you still writing your answers in radians. And some of you might be thinking about Unit 3 right now and saying, how come we're not dealing with those restrictions like quadrants 1 and 2 or 1 and 4? That's because we don't see the word arc. If we don't use arc sine, arc cosine, or arc tangent, we are not dealing with the restrictions. So you're just dealing with one rotation. All right, next example. Let's isolate the trig function. So like the last one, let's move the 1 to the other side first. 3 cotangent squared of x equals 1. Let's continue isolating the trig function. Cotangent squared of x equals 1/3. Now eventually here we're going to have to take a square root, but let's use the idea of reciprocals here. Cotangent is not as familiar to us as tangent. So if cotangent squared x is 1/3, that means to me that this statement is equivalent. Tangent squared of x, or the reciprocal, must be equal to the reciprocal of this number, of 3 over 1. So I know that tangent squared x equals 3, and now that I'm more familiar with tangent, now to get the tangent alone, I can take the square root of both sides. If I do so, I would get tangent of x equals plus or minus the square root of 3. And so what we need to do is remember what our tangent values are on our unit circle. The tangent value in these red dots is always root 3 over 3 in some form. At the 45-degree angle, the tangent value is always 1. And at the 60-degree angles, which are all of these green ones here, the tangent value is some sort of root 3. Now, if you think about quadrants again, tangent is positive here, tangent is positive here, and it's negative in this quadrant and this quadrant because of the y divided by x. So it looks like the places that the tangent is either positive or negative root 3 is every time I have a green dot. So my angle answers would be pi over 3, 2 pi over 3, 4 pi over 3, and lastly 5 pi over 3. So this next problem, I would like for you to get a head start on me. What I would suggest is treating this problem in a very similar way to the one we just solved. So if we go back to that briefly, I would isolate the trig function, and then I would think about what the reciprocal function is to make it easier, and then use your unit circle. So please pause now and try this one on your own. Okay, so my final answers were the angles of 0 and pi. Notice I did not say 2 pi because we're dealing only from 0 to 2 pi, 0 included, 2 pi not included. What I did first was add the 1 to both sides, got secant squared equal to 1. I then noticed that secant and cosine are reciprocals. The reason I did that is I'm a lot more familiar with cosine than I am with secant, in terms of the unit circle at least. The reciprocal, funny enough, of 1 over 1 is still 1 over 1. So when I take the square root, I get cosine is plus or minus 1, and the two places where my x value is positive or negative 1 are at 0 and pi. Okay, this next problem is the first one that we do not have only a single trig function. And so my goal is to try to change this so that everything is in terms of a single trig function. And we can definitely use our algebra skills, and we can use identities. As a suggestion first, whenever you see something that's squared, I would suggest making it equal to 0, because probably in some form you're going to have to factor. So I subtracted this term over first. Now, this is your choice, if you prefer sine over cosine or cosine over sine. We can definitely use the Pythagorean identities here to replace one of these squared functions with the identity, so everything's in terms of one trig function. So what I'm going to do is I'm going to replace sine squared minus x with 1 minus cosine squared x. That again comes from the identity. And then I'm going to keep this the same, because now this whole equation has only cosines in it. So if I simplify this a bit, this is really 1 minus cosine squared x minus 3 cosine squared x's equals 0. These two are like terms because they're both squared. So that's 1 minus 4 cosine squared of x's equals 0. Now, the problem's in terms of only one trig function. So let's solve this like the ones we did before. Let's isolate the trig function. Negative 4 cosine squared x equals negative 1. I'm going to divide both sides by negative 4, and I'm going to get cosine squared of x equals positive 1/4. The trig function is not isolated yet because I need to take the square root of both sides. And if I do that, I would get cosine is equal to plus or minus square root of 1 is 1, square root of 4 is 2. So we're really saying where on the unit circle are my x values plus or minus 1/2. Well, if I look back up here, the places where my x values are plus or minus 1/2. Here, 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 and here. So my angle answers, one rotation, would be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. I picked this example because some of you might have noticed that these were already the answers to a previous equation. It is okay. You could have two totally different equations and you can have the same final answers. It's based on what the equation says. Okay, the last one for this video is another one that you might notice that not everything is in terms of one trig function. So my suggestion again would be, because you are dealing with, you have a squared in some way, I would get everything to one side. So I'm going to subtract these two values over. I'm going to subtract cosine, and I'm going to subtract 2 so that everything is equal to 0. I then again notice that I don't have the same trig function, but I do notice I have sine squared x. So just like the last example, I'm going to replace this with 1 minus cosine squared. Now be careful though. The 2 in front has to multiply all of sine of x. So it has to multiply all of 1 minus cosine squared of x. Then the rest of it stays the same. So let me distribute and keep simplifying this. This becomes 2 minus 2 cosine squared x minus cosine x minus 2 equals 0. Let's see if that helped. Well, this is nice. The positive 2 and the negative 2 cross out. So I'm left with negative 2 cosine squared x minus cosine x equals 0. Both of these terms are negative. So if I divided every term by a negative 1, I would get rid of the negative signs. So let me do that. So I get 2 cosine squared x plus cosine x equals 0. And then the question is, what do I do now? Well, it's equal to 0. So when something's equal to 0, my gut tells me to factor. It doesn't look like we can factor in the normal sense, but I do notice that there is a greatest common factor between these two terms. I can take out a single cosine, and then I'm left with 2 cosine of x plus 1 equals 0. And so at this point, we can use the zero product property and set both of these pieces equal to 0. I know that cosine of x equals 0, and I know that 2 cosine of x plus 1 equals 0. So this first piece, again, there's been a lot of cosines in the last couple examples, but that's okay. We're saying where does the x value equal 0 on the unit circle? So let's look. The x value is 0 at pi over 2 and 3 pi over 2. So that's two possible answers. X is either going to be pi over 2 or 3 pi over 2 as possible angle answers. So that's done. This second equation, if I solve that, if I subtract the 1 over and then divide by 2, I get that cosine of x equals negative 1/2. So where on the unit circle does the x value equal negative 1/2? Well, let's see. X is negative 1/2 here, and x is negative 1/2 here at 2 pi over 3 and 4 pi over 3. So my other two answers are at 2 pi over 3 and 4 pi over 3. So it's important to, again, have your unit circle in front of you. It's very important to remember that your Pythagorean identities can come and help you. Remember that you can use different algebra skills to help you. Here we did greatest common factor to help us. On the previous example, we ended up using square roots. We ended up using square roots quite a bit. We used the reciprocal functions to help us. I remembered that sine is y and cosine is x. If you're interested, this third problem, we could have even solved a different way. If we had secant squared of x minus 1 equals 0, we could have factored this from the beginning. We could have said this is secant x plus 1, secant x minus 1. Then we could have, set these both equal to 0 and solved. So factoring is definitely an option too. So yeah, these are, I think, kind of fun to solve. Just please don't forget that anytime you take a square root, you need the plus or minus. If you don't have the plus or minus, you're going to be missing some answers. So feel free to go back and redo any of these as well. Always good to redo problems you know the answers to. All right, thanks guys.